Hello and welcome. In this video, we're going to sync the input across the network and move our entities using input. So first we need to install the input system. And right now we can instantiate a prefab by pressing a key on our keyboard. So I'm going to go ahead and create a new type of prefab and name this one player. And to visualize it, let's create a capsule. And we can adjust the position of our capsule and maybe give it a little bit of color to make it look different than the other prefab that we have. So I'm going to create a prefab out of this one, delete that, and also add the ghost authoring component to our player prefab. Also change this to predicted and has owner. Now, if we go to our prefabs script, I'm gonna rename this to unit. Also rename this one to unit, and I'm going to create a new game object for player prefab and also the entity prefab for our player. And inside the bake, let's move this condition to here, and I will create two entities to hold our prefabs. Also, let's bring this here. So if the authoring unit is not null, then we're gonna get the unit prefab for that, and we can do the same thing for our player prefab. And when we are attaching the prefab's data to our entity, we're going to assign the value of the unit and player entities. Now our prefabs manager contains two different prefabs that we can instantiate in our server system. Also, we need another script to attach to our player. Let's just name it player. And if we open this, let's say it has a float for speed. And we also need an I component data for speed. Let's name it player data. And then simply we can create a baker to attach that component data to our entity. So in order to sync input across the network, you need to use input data. So to create that, let's go ahead and create a script first. I'm going to name it inputs data. So if we open this, let's clear it. We can create a input data. I'm just going to name it player input data. And for the ghost component, we say all predicted. So when we attach to our player entity, and then if we change the value of this component data, then the values are going to be synchronized across the network with the server and all other clients, and we can use those values to make any changes, for example, move our entities. So I've created a float2 for move and an input event for jump. I'm just going to use the move in this video. And we need to attach this player input data to our player entity. So here in the player baker, I'm going to also add another component to our entity of type player input data. So now whenever our entity gets instantiated, it has a player data attached to it. Also, it has a player input data attached to it. So the player data contains just the speed, but the player input data contains the input component data of move and jump. So back to the editor, if I select my player prefab, here I can simply attach my player script. And now I can select my prefabs and assign the value of unit and player. And let's go to our server system. And here in the on update, whenever we detect a new connection from a new client, here when we are getting the entities with network ID but without initialized client, then we can instantiate a player prefab for that connection. I'm just going to get rid of this send message RPC and then get a reference to the prefabs data by getting the singleton. And if our prefab entity of player is not null, I'm going to instantiate it. And then I'm just gonna put it on a random position and then assign the network ID for it. We have the network ID here and we assign it to the ghost owner, which means this client owns this entity now. And we also link it to the connection. So it's gonna get destroyed with the connection. And if I go and play the game now, here it is, our player prefab is instantiated. So let's go ahead and start moving the player prefab. In order to do that, we need some input. So let's go ahead and create a folder. I'm just going to name it input, and inside this I will create input actions, name it controls. And if I open this, I can create a new action map, name it player. And for this one, let's create an action, name it move. So it's going to be of type value vector2. And I'm going to delete that default binding, create a new one of this type, name it WASD. So for the up, it's going to be keyboard and W. For the down, I'm going to choose S. Left is going to be A, and the right is going to be D. And let's save this, close this, and I am going to generate the C# class. And because we are using the W key, let's go to the client system. I chose the W key to instantiate the units. So instead, I'm just going to use a space, and I am going to remove this part when we are sending a message RPC. Now with a space, we can instantiate new units. So to assign the value of our input, let's go ahead and create a system. Here I am going to create a new C# and name it inputs system. So if we open this, it should be of type system base, and we need to add a filter to run only on the client. We don't need to do it on the server. Also, let's put it on the ghost input system group. And here I can go ahead and create a new variable of type controls, which is the type of input we created here. So we are going to create a new input in the onCreate and assign the value, and then we're going to enable it. And we create a builder to make sure update runs only if there is a player input data in the world. So that is required for the update. And then we can go ahead and disable the controls on destroy, and inside on update, we are going to read a vector2 from our control player move. And then we're going to do a query to get all the entities with player input data attached to them. And they also need to have ghost owner is local, which means you are the local player and you are owner of this entity. So this way, clients cannot affect other clients' data. So you can only change this if you are the owner and if you are the local player. And then we're gonna change the value of the input to the vector2 that we got. Note that this is the read-write reference of the player input data. Now, all that remains is actually go and move the player entity. So to do that, we need to create a new system. So here in the scripts, I am going to create a C# script, name it player movement system. So we can open this up, and it should be of type iSystem because we're going to use the jobs. And inside on create, we're going to create a builder and make sure the update runs only if there is an entity in the game with player data, player input data, and local transform attached to it. So it needs to have all three in order for the update to execute. So that's our on update. Let's also add the burst compile here. Now we need a job to move the player transform. We can simply go ahead and create a job here. I'm gonna name it player movement job. It's gonna be public partial struct of type iJob entity. So it has a delta time. And for the execute, we are going to get player data, player input data, and local transform. And when we got all of those, the transform is going to be read-write, and we calculate a float tree movement using the input and player speed and delta time. And at the end, we're going to change the position of our transform. And here inside on update, we are going to create a new job and then schedule it. Now, if we go and play the game, we should be able to move our entity around just like that. And when we hit space, it's gonna instantiate some units, and that's it. Let's stop this. We could also get a build for the project and see how it works. Here we go. So I'm going to start the editor first, and we can go ahead and start one of the clients and maybe another one. So you can add as many clients as you want, and each one of them is going to have their movement synchronized across the network. I hope you enjoyed the videos so far. Please make sure to like and subscribe the videos, and thanks for watching.